Hi guys, my name is Alex and I'm the lead developer on Double Barreled, a game which is being developed by Devoid Studios. Today I would like to show you the system that we've developed for our game. It's a mesh fading system which basically hides any geometry that comes in between the camera's viewpoint and the character that the camera is following. Now, I'm sure you've seen this in games like Diablo or Torchlight even. Torchlight is a bad example because they don't actually hide the geometry. Rather they show an outline over the character. Diablo is is a lot better example. All right, so here's our little dude. He's looking spacey and everything. So now, basically, we have some geometry here which would obscure the character as soon as he moves under it. So you will see it here, and then the beam disappears. Now, this basically is what the whole thing is all about. However, there are some differences between some systems which are out there on, let's say, the Unity asset store, which utilize the layering system in order to handle this sort of functionality. Now, the problem with using the layers to do this is that there is a limited number of layers, and usually they are more needed elsewhere in the game. And even if you did have enough layers to do this, what this means is that you would have to assign the geometry that you want hidden to a particular layer. Now, if you need some other functionality and layers were used by some other system, and let's say a more important system in your game, obviously this would pose a problem because you can't have two layers assigned on an object. So our system doesn't use layers to do this, and which makes it pretty neat and easy to use, and it's actually a lot simpler than it sounds. Now, there are some neat features as well. For instance, we also have a parent-child synchronization for faded objects. For instance, you see that these beams sort of form a logical block, let's say, with this column. So when the column is hidden, the beams are hidden as well, because it would look a little weird if they didn't disappear with the column, I guess. Of course, this is not a requirement. I mean, you can do it without linking, without synchronizing. Fading of two or more objects, and obviously, as soon as we move out, they all appear. All the geometry appears. Now, you will also notice that the parent-child relationship here that controls the fading, the children can disappear independently without needing the parent to disappear, obviously. And that's pretty much it, really. Now I will show you around and explain how we set it all up in the scene and how it all works in code. Alright, so here's our scene, and now we can see how we set the whole thing up. Now, the first component that I'll show you is the manager MeshFade. Now, this is basically the entry point into the whole MeshFade system, and this is what starts it up, warms it up, and does all the other kind of boring stuff. Now, if you'd like to do some custom integration, or let's say you need some access to some of your other subsystems or something, and you need a logical place to put that in, for interaction between the MeshFade and the rest of your game. probably this is the best place to do it. It's a singleton class. Putting it in your startup scene is the way to do it, and then the rest of the MeshFade system always sees it and has access to it. And if you add your custom stuff to it, it will be immediately available to the rest of the system, so you don't really have to look around for stuff and create complicated chains or dependencies and whatnot. Now, but let's move on. Really, that's not fun. Now, here's the fun component that does most of the work, and that's the MeshFade camera controller. Now, you assign one of these to every camera that needs to fade out. That needs to fade out objects that come between the target and the center of the camera. So what happens here is that we can assign a target, or if you don't have a target, you can just ignore this and set it to none. What this means is that every frame, a ray is cast from the center of the view of the camera down to either the target or infinity, and any MeshFade component that gets hit by the ray cast will get faded out, provided its fade group falls within the list of fade groups that should be affected by this controller. Now, fade groups are a lot like layers, really. The only difference is that you can have as many as you want. So if you wanted, let's say, 6 fade groups for whatever weird reason, you can, have this one is this and that and whatnot. So you can have as many as you want. Now, the names you specify here will be matched against the fade groups that you specify on the MeshFade components, which you attach to the actual game objects that need to be faded, or rather to the renderers. Now, in our case, we don't really have any weird setup, so for us the default group is good enough. But if you needed a setup where, let's say, you have more than one camera and some cameras can see through geometry and others can't, you can set this up in any way you like. Basically, this is what this parameter is there for. Then we have the shader. Now, the shader that you specify here is the shader that should be applied to the renderer components, or rather their materials, when the manager decides that they should be faded out. Now, usually most shaders don't support transparency in the way that we need for the system, meaning that the alpha value is used for something else, not to make it less opaque and by extension more transparent. So what happens here is that when the MeshFade camera controller encounters an object that it needs to fade out, it will swap the shader that is currently applied to the materials of that object with this shader. And from then on, basically the object will get faded out, and when it fully fades back in, the shaders will be swapped back, and the old shader on the object will be restored, and the shader will be taken out, thus making the object appear as well as it was before. Now, there may be situations where your shaders that are on the objects already do support transparency. So in that case, you don't have to specify anything here. So you just set it to none, and it will not attempt to swap out the shaders. It will just attempt to change the alpha values on the existing shaders. And if they support the transparency the correct way, they will get faded out. Now, then we have the fade in, fade out speeds and the fade out amount. Now, the speeds are pretty self-explanatory, but the fade out amount basically controls the amount of fading that should be performed on the objects that get hit by the raycast. Now, I have 0.5 specified here, and I will demonstrate what that looks like. So here's our space dude again. So now if I go under this beam, you see it remains partially visible. Now that may not look like 50%, but you know, it is as far as we're concerned. So obviously if I go here, you see I can see part of the column and I can see some other stuff. Now, this is not the kind of look that we will go for, but you know, if you have other requirements, you can always adjust this to be whatever it is that you need. Now, I'll go back and change this to 0. So now we'll fade out to black. Let's see. Okay, so here we space again, and there you go. The object disappeared completely, which is pretty cool. Alright, so now let's see the rest of the components. So this part is pretty clear, I suppose. So now we can move on to the actual gameplay scene. Here's our awesome level, and we can see how we set the whole system up from here. So we have our beams. I'll take one of them. So we have the collider. Now this is basically the collider that gets hit by the raycast from the mesh camera controller, and we also have two more components here, which make the whole system work. Now, I will explain the fade sync later, and we'll start with the MeshFade. So, like I've mentioned before, on each MeshFade component, you have a fade group. Now, obviously, here you don't have multiple fade groups because it doesn't really make much sense for one object to belong to multiple fade groups, at least not in our case. So this is the fade group that this object falls under now. We will we'll change this to demonstrate how the system will react when it encounters a fade group that it shouldn't fade out. Now let's go back to our startup. Let's just quickly check that we have our we have a little bit of a mix-up. We need our transparent diffuse shader. Here, of course, search is always better. So here's our transparent diffuse, and this should be faded out to black. Now let's start this up. So now, since this beam is no longer on the default layer, it will now get faded out when our character moves under it. Now, the server racks, for example, here, they are on the default system, so when we go there, they get faded, which is pretty cool. Alright, so let's go back to our level here. Now we can put this back onto the default layer. So this is basically how that part works. Now, the colliders are basically a list of colliders that are part of the whole logical check against the camera viewpoint, and raycast. You can have more than one if you have complicated objects or you have some interesting setup. But in our case, a simple box collider is enough. We then have the renderers list. Now, the MeshFade component doesn't automatically assume that whatever renderer it finds in the hierarchy below itself should be faded out. Maybe in most cases that is the way to go about it, but in our case we had situations where we don't want all the renderers to be faded out. So basically all you have to do here is you pick and choose the renderers you want faded or not. So now I could, let's say, take this render and take it out of the list, and then it wouldn't be faded when the rest of the object is faded. So you can again use this to achieve interesting scenarios. And lastly, we have the shadow casters. Now, another important point to mention is that when the component gets faded out, if your shader does not support casting shadows by visible geometry, obviously it will disappear from the scene, and so will the shadows that it was casting. Now, in certain cases that's okay, but in cases with level geometry, it just makes it look weird. Now, if you're not using baked lighting and you need, and your shadows are dynamic, this looks really weird. Now, there are two ways to go about it. You could use the transparent shader, which was specified before on the camera controller, that does support casting shadows whilst being invisible. Or you can have, or you can use something like the transparent shadow caster shader, which is available on the Unity community wiki. And you can basically set up a mesh here, maybe a simpler looking mesh with a lot less polys and stuff. It depends on your requirements. Assign that shader to it, and you will specify that game object in this list, in the list of shadow casters. The way it works is that as soon as the renderers mentioned in this list get faded out, all the objects in the shadow casters list are made visible and basically enabled. So if we follow our previous example, as soon as the beam is faded out, the component that has the invisible shadow caster shader assigned to it will be shown immediately, so your shadow basically will not disappear. Of course, you can use it to achieve other functionality. Maybe you have some weird desire to do something extraordinary here. But just keep in mind that obviously assigning objects which are not faded out or that don't fall under this logic, it will just look weird unless that's what you're going for. Now, the last component that makes this whole thing tick is the fade sync. Now, what this does is basically it tells this MeshFade component to react to fading in and out of another component. Now, in our case, you will notice that the component we have specified as the parent is our column. Now, this column, when it's faded, we would like the beams to fade out as well. So for this reason, we attach on each beam, you'll notice here, a MeshFade sync. Now, what happens is this component subscribes to some events from another MeshFade component and simply reacts when it gets faded in or out. Now, can use a more centralized system whereby you have, let's say, one parent game object that says, synchronize fading between this parent and these children. So you can have like a bunch of other MeshFade components specified here, and it will basically just fade them out. In simpler setups, let's say you can have 0 children, then that means it will just attempt to find any suitable MeshFade components in its own hierarchy. In which case, let's say here it will find this MeshFade component, which is exactly what we want in our case, because this is what we're trying to do. We just want to react to the fade component, to the fade events from this parent, and fade ourselves out. And that's pretty much it. This is really all you need to do in order to set this whole thing up. So a quick recap is that each component that you would like faded needs to have a maximum of 2 extra components. That would be the MeshFade and the MeshFade sync if you need the hierarchical link between fading components. And the MeshFade only needs a number of colliders which it should check against for raycasts from the camera, and the renderers that it should fade out. If you have shadow casting geometry that needs to be visible after the component is faded, you can specify them here and they will appear when everything is faded out. Now, just to clarify one more time, we do not utilize the layering system, and you can see here that the beams are on the walls layer and the servers are on the props layer, and you saw that they're both getting faded, and we did not need to specify their layers anyway. That's pretty much it for the setup, and now we can look at the code. Alright, so here's our code, and we'll start by looking at the manager for the MeshFade components. So as you can see here, we have a very basic registry, which is just a dictionary keyed by colliders with a list of MeshFades. Now, the reason it's done like this is to safeguard against the cases when you could have, let's say, set up a scene so that you've used one collider for many MeshFades, either deliberately or by accident. So it will still be possible to resolve the MeshFades and get the correct components based on a single collider. Now, as I have mentioned before, this is a singleton class, which lets you very easily access it from anywhere, either in your code or, in our case, it makes it very easy to access it for our components, simply by invoking manager meshfade.instance, and we get the instance of this manager, as you can see here in the awake. Now, this is basically the start method is more for our system, for our internal use, whereby we have a lot of managers and some of them take time to get ready. So there is this basic flag that we set to make sure that a particular manager is ready or not. Now here comes the more or less interesting stuff. GetMeshFade is a method that you can use, or that we use, to get a list of MeshFade components that are registered against a particular collider. And at the same time, we pass in the groups, groups being the MeshFade groups, that we would like to check the MeshFades against. So when a particular collider is hit by the ray cast from the camera, the camera controller will pass the list of its fade groups together with the collider. So the manager will match those groups to make sure that only the MeshFade components that match the groups are returned. So as you can see here, a little below, we check if we have the collider in the registry, and if we do, we simply return the MeshFades which match the particular fade group, any of the fade groups that we provide. Now, there are a couple of utility methods here which are actually used to register and unregister colliders. Now, this registration takes place when a MeshFade component is instantiated in the scene. So if we quickly jump here to the MeshFade component, which we'll look at in detail later, you can see that here it will attempt to register itself with the manager. Now, the reason this is important is because obviously we don't want to make many checks in something like an update loop on the MeshFade camera controller, which basically fires every frame. It would be very costly to do so. So the colliders which need to be part of this whole MeshFade system will register themselves at startup, or when the components, when the objects that they're attached to are created, and basically then it's just a quick lookup on the hash table to see if the collider has been hit, and also to see if the collider that was hit has any of the MeshFades that should be faded out. And basically, unregister method is just used by MeshFades when they are destroyed to remove themselves from the registry. Not really a big issue because unless you have thousands and thousands of MeshFades, you don't really have to unregister them because they won't take that much memory or something, because it's just a bunch of references. Anyway, so this is the manager. It's a pretty simple class, it doesn't do much. The camera controller, on the other hand, does quite a bit. So, as you saw before, we have our target, which may or may not be set, not really important. We have the fade groups, the shader to use, and fading amounts and speeds. There are also some other utility properties. The most important of these are these two, is the last frame hits and current frame hits. Basically, as you will see here, every time an update is made by this controller, it will store all the MeshFade components that were hit by the raycast. Now, of course, this happens after they have been resolved against the manager, and basically the matching MeshFades were retrieved. So what happens here, as you will see in a bit, a bunch of checks, and then a raycast is made. As you can see here, a raycast is made to determine which colliders have been hit. Once we have the colliders, you see here, we go through them and we basically ask the manager to give us the MeshFades that match our fade groups. And then they are checked against the hits of the last frame. Now, this is important because obviously you can have the fade out of a particular mesh could take a lot of frames because it's slow and is not something that happens immediately. Even if you had speed set to 0, which is immediate, you would still most likely hit a couple of frames. Now, when the collider is hit again, and it goes through this check. Now, if it is part of the list of last frame hits, nothing will happen to it. Basically, it will be removed from there, and it will not be processed because it's already fading out, and where simply the camera, let's say, is not moving and is constantly hitting the same collider. So nothing needs to happen there because our colliders are already fading out. And basically that's pretty much it. This is the really important bit. Colliders which were in the last frame but are no longer in the current frame hits, meaning all the colliders that we hit this frame, the difference between them must be faded in, because as obviously we did not hit them this frame. So here you can see that we go through all the remaining hits from the last frame, and we start to fade them in, because at this point this is what needs to happen. And once the fading process is started, the frame hits are cleared, and only the current frame hits are added back onto the list. And the same happens every frame. So this way you can stay staring at the same collider, and it will be its fade operation will be hit only once. Now we go on to the MeshFade, which is a big component, and this is basically the workhorse of the entire system. So what we have here, obviously the fade group that the particular MeshFade component belongs to. We have its colliders, renderers. There are two events that you can subscribe to, fading in and fading out. These are obviously fired when they said the events occur. And there are also a couple of properties which you can use to determine whether the component is currently fading out or fading in, whether it's fully faded in or faded out, and you can also retrieve the amounts determined for this component by the camera controller, and actually only by the camera controller. So you can easily find out from a particular MeshFade what it was meant to fade out to, what is its current faded out amount, and the speeds, as well as the shader that was meant to be used for this operation. Now, if you remember, the shader is the shader that you set on the MeshFade camera controller. Now, this shader will later be assigned to the MeshFade component, and you have a reference here in case you need it. These are basically some utility properties to facilitate fading in and fading out processes, and dictionary for the shader swaps keyed by the renderer. So each renderer, since you may have actually a lot of renderers under one MeshFade component, each one has its own shader. So obviously we need to keep a correct list of shaders and not just assume that it's the same shader on all of the renderers. Now, when this component starts, we are using coroutine here. The reason for this is that we need the manager to be available. Now, as you may recall, I said that in our case some managers take time to load, so as a matter of habit we have this everywhere. The start of the MeshFade component will wait indefinitely. Basically it will have to wait until the manager that it needs is ready. Now, this is something that you may or may not do in your game, so if it's something that you don't want to do, feel free to remove it. Now, the renderers and the colliders are checked because obviously we can't do anything if we don't have either of these. And the refresh colliders. Now, this method, as you will see now, basically is used to retrieve all the collider components in the hierarchy of the colliders that were provided. Now, what does this all mean? We're using a custom extension method here, which is a lot like the Unity API get component methods. The only difference here is that this extension method checks the entire hierarchy of the game object, including its children. This is useful in cases when you specify a game object which may have the component you're looking for, 3-4 nested levels down. So this is a simple extension method that just goes through all the components available on the item and just finds the one you're looking for. Obviously generic to make your life easier. So this is the purpose of this method. Now, so once we've gotten all the colliders we need from the component specified, from the game object specified, we go on to gather the shaders from all the renderer materials. So we go through every renderer, and we take the shader and we add it to our little original shaders registry that we have, which I showed before. Once all this is done, we register the colliders and this MeshFade component with the MeshFade manager. So from now on, whenever a collider is hit, we will know which MeshFade component to fade out. And again, like I mentioned before, the shadow casters are warmed up, and basically we disable them because we assume that this component is fully faded in. So the MeshFade, so that the shadow casters need to be faded out. And from this point onward, we only need to do two things. We either fade out the component, the MeshFade component, or we fade it in. Now the fade out, basically what happens here is you provide, or you can provide, if you're going to use it manually, the amounts, the speeds, and the shaders and whatever. In our case, this is handled by the manager, and once it comes here, basically it just makes sure that it's not going to do something stupid by, let's say, fading in or fading out something that has already been faded out. It will do a bunch of other checks to make sure that everything is logical, and once that is done, it will start a coroutine to fade out the necessary renderers. Now, it's important to mention here that the fade outs happen in coroutines because once they start, they may take many frames to complete. Now, while this is happening, you can easily stop the fade out process by calling one of these methods, stop fade in or stop fade out. Now, what this method does is simply sets a flag that says stop fade out. Now, if we look at either of the coroutines for fade out or fade in, there's a while loop here to continue fading out, so to continue smoothly fading out or fading in the renderer as long as the stop flag is not set. So if you call this, and let's say 5 frames down the line, you call stop fade out, obviously on the next iteration this will stop, and the coroutine will terminate and will not proceed with fading out anymore. And obviously when this happens, the amount of fade is set to its expected value. So for example, if you're fading out and you stop it, it will fade out to the target amount basically in a single frame immediately. Now if this is something that you don't want and you actually want it to stop fading at whatever amount it was at and not just zap quickly to the end, you can change this, and instead of and basically not reset these amounts and just leave them as they are by simply commenting these to clients. What will happen is that when you restart it or you start fading in, it will just continue from the same amount where it was left off. And if we look at fading, it's pretty much exactly the same, only the parameters are a little simpler. We only need the speed here, because the assumption is that we have already started fading out. So on fading, we have all the necessary information that we have the shader, we have the speed and everything. So again, a few checks to make sure that everything is in order, and then we fire off the fade-in coroutine, which works a lot like the fade-out coroutine. It has the flag to stop it at any iteration of the while loop, and then it does a bunch of checks inside to make sure that once the fade-in is complete, the shaders are swapped back and the shadow casters are hidden and so on. Again, to stop the fade-in, it's enough to call this method in case you're doing something yourself, and these are not managed by the MeshFade camera controller. And again, if you wanted to stop, let's say halfway faded in, it's enough for you to comment these last 2 lines, just like on the fade out, in order to leave it at the amount of fading that it had. That's pretty much it for this component, for the MeshFade. And now we'll quickly look at the sync. Now, this is a pretty simple component in that when it starts, it will obviously it requires a parent, because otherwise it doesn't make any sense for this component to exist. It will subscribe to the 2 events on the parent, the fade in and fade out, and whenever they're fired, it will attempt to fade in or fade out the children that we specify. So you will notice here, when the fade in takes place, every child MeshFade component will be faded in. And if we look at the fade in child, it simply goes through the list and calls the fade in component, method, provided is not already fading in. This, for example, another display of usefulness of that property. I mean, you can easily check if a component is currently being faded in. And basically the same happens on the fade out. There is no difference here. The only obvious difference is that we are calling fade out rather than fade in. And on destroy, all we have to do is just remove the events, the subscription to events. And that's pretty much it. This is how the whole thing works. You can read the full tutorial text on Unity3D, and basically, if you have any questions, leave us a comment, and we'll try to answer it the best we can. Thanks for watching. Bye.